Right. Question 5. Use the Myers theorem. Alright, to evaluate. To the 16. Alright, first of all we have to draw this on an Argand diagram. So that's your imaginary and your imaginary and real. So where is it? It's 1 minus I. It's down here. 1 minus I. Okay, so that's 45 degrees, isn't it? So that's pi over 4. Because this is pi, so pi over 4. So if I start at this point, when you're measuring in an angle, you have to start here and you have to go around. That's the positive direction, isn't it? So from here to here is how much? Pi. Alright, so that's pi. And from here to here is 3/4, isn't it? So that's 3/4 pi, the bottom bit. So the top bit is pi, and you can write pi, you can write 1 as 4 over 4. So you add 4 over 4 and 3 over 4 and you get 7 over 4. So that's called the argument. First of all, the argument, let's say this complex number is called so z. So the argument of z, that means the angle, the argument is equal to 7 pi over 4. Right, so the next thing you have to get is the modulus, the distance from there to there. And we know from previous examples, so the modulus of z. Square root of a squared plus b squared. Put it in brackets. Why do you put it in brackets? Because there might be minus values to keep everything right. Alright, so the first value is 1. So we'll just do there. And the second value is minus 1. If you didn't put brackets, you'd have plus minus 1, you get confused. Right, so you do square root. What's 1 squared? So 1 minus 1 squared. So minus 1 squared is 1. So square root of 2 is the radius. So we have the angle and we have the radius. What do you do now? So when you have the angle and have the radius, you write your polar form formula. Or what is it? Cos theta plus I sin theta. And so we have the radius, square root of 2. And we have the cos of 7 pi over 4 plus I sin 7 pi over 4. So we just call that's z, isn't it? That's the polar form of the complex number. What do we have to do now? In a minute, we have to find what z to the 16 is. What formula do you use? What's it called? To get that, it's called the general polar form. How is the general polar form different to the polar form formula?
You put 360, n 360 after.
Yeah, so z to the n is equal to, I'll do it in red if it'll work, or blue. So z to the n, r to the n, cos theta plus 2n pi plus I. No, sorry. Wait that one. No, sorry. Using the Myers theorem, what you do, it's sorry. Z to the 16, isn't it? I was writing down the formula to use to get the complex roots. So it's the square root of 2 to the power of 16 cos. So 16 times 7 pi over 4 plus I sine 16 times. That's a 7 pi over 4. Right, so in the calculator, 16 times 17 divided by 4. 28. Alright. So 28 pi, isn't it? So that becomes 28 pi, doesn't it? Yeah? You're with me here. Right. Square root of 16, square root 2 to the power of 16? 256. Now, if I start off with a unit circle, watch. If I start off here, that's pi, using 28 pi, pi, 2 pi, 3, 4, 5, 6, 8, 10, 12, 14, 16. Where will I end up? I'll end up here when I go around 28 pi. Alright? So what's the value? What's this point? This point is 1 comma 0. Which cos or sine comes first? Cos and then sine. So the cos of 28 pi is the same as the cos of or 0. Yeah, cos of 1. Cos of the cos of this angle here is 1. That's 1, and the sine of this point here, sine is 0. Right, so the answer is 256. 256 times 1 is 256 plus 256 times 0, 0.